Welcome back to video number 6. We're going to dive into HLODs for UEFN or Fortnite and optimizations for it. This is GameDevMicah on Twitter, Discord, and Micah Berninghausen on LinkedIn. Hit me up. Let me know any questions or any changes you might have on this. Please comment down below too. These are just my meeting notes and what I figured out along the way. They will be wrong and they will change over time. It's up to you to hunt down what works for you. Alright, so we're talking about HLODs, or hierarchical levels of detail, how to remove or stream out actors in your world and replace them with a instance on the GPU or a merged mesh custom made to render faster and have less things to be considered in the world. Some of the things we're talking about here is that you need to enable streaming in order to start using the HLOD system. You need to check off enable grids. And we're looking at the cell sizes and loading ranges. Loading ranges is how far you will spatially load in assets in place of the HLOD or where the conversion is. And then the cell size we're looking at here is how big of tiles of areas and groups of actors are merged into the same mesh or added to the same instance. So the effects of changing your cell size, the bigger the cell, the more likely you are, if you're using instancing, to find other instances of the same mesh and get the advantage of combining them together. Versus the HLOD system is just going to put everything together in a new mesh and cost you on your package size. The distance it will load in. The further you load in or spatially stream in things, the heavier your memory will be on your thermometer, because you'll be actually having the actors in the world instead of the instant static mesh or merged mesh lightweight representation of it. So the loading range does affect your memory thermometer because you're going to load in or spatially load in more actors. And the cell size affects the efficiency of instancing and also makes the size of the generated mesh larger for larger cells. I avoid merged mesh HLOD at all possible, if at all possible, and use custom meshes and instancing instead. HLOD instances are identical to static meshes at the highest level of detail, or only level of detail that you have in the mesh. So if you have a mesh that doesn't have any levels of detail and you make an instant static mesh out of it using the HLOD system, it will be that one mesh that is your only level of detail, LOD 0. If you are using a merged mesh, it's going to try to do the same thing, grab the lowest level of detail, but if you don't have any other levels of details, it will just grab LOD 0. This is a way for you to kind of game that system. Instances, pretty good to just go ahead and use those and the lowest level of detail, and it will always look just as good as you want it to. Only custom meshes for sure can use the instancing system. UEFN props, I don't think the material is enabled when it was baked, and so you just can't use instancing. Sucks. Custom meshes can use HLOD. It says right up to the camera, so we'll show that. If only one LOD. That way you don't have any cheaper looking or badder looking, or that you don't lose any detail, and you can just slam it all on the HISM. But they will need collisions or blocking volumes if you do so, because I found that on the client, HLODs seem not to have any collision. So you could use some custom blocking volumes, which I do. Then you can auto instance it with HLODs, which we'll walk through later, and use the collisions from this only works if you're cool streaming everything out and never loading streaming or using spatial loading, which might not be that useful if you have a bunch of devices out there and you're not pooling them, because you could stream out devices where if you are never streaming, if you have a streaming distance of 0, the devices will be streamed out immediately, so you'll probably have to turn off device streaming. So there's some harassment to do that funky thing. But at the very least, you should be using HLOD instances instead of merged mesh, and have it at your cell size to try to capture GPU cloning instead of extra vertices by merging a mesh into a new mesh, which is what the merged mesh system does. HLOD layers is really just the setting saying when we bake a merge mesh HLOD and make a new texture. What textures are we going to go ahead and include in that new texture? Your metallic, rough, or speculator map. If you cannot be using merge mesh HLODs, you don't have to worry about the merge mesh settings for material as much, and that's the only thing in a HLOD material, or what's this thing called? A HLOD layer is just the merge mesh settings from what I saw. Building HLODs, delete first. I found that if you hit delete first, that's better than building, because maybe the building just sees the old ones and won't overwrite them or something. So I'm always, when I build HLODs, I delete the HLODs, let that go through, and then I build HLODs, and that seems to be very consistent. Seeing the HLODs in editor, we covered a bit earlier that in editor settings, there's an option to enable seeing HLODs, so you need to check that. At that point, you'll be able to see these HLODs in the outliner. Then what you'll want to do is click the pawn icon next to them, or the pawn icon next to them. And when you do that, you'll be able to actually see them rendered in the world. When that happens, you can go ahead and hide the actors that they represent, and then you can see what the actual HLODs look like. And that's what I'm showing here, is turning on the view of those different generated HLODs. Preview grids. We talked about the preview grids, or showed them up above. This is previewing the grid layout, and that lets you get a visualization so you can see what's included in what tile, how big the tiles are, and you're really trying to sort of, see how much data loads in for each tile and stuff like that. ISMs are cheap to render and cheap to load in versus the merge mesh, because the merge mesh is a really big mesh and a really big texture that has to be loaded in or streamed in for every tile when you load out your assets. HLOD layer settings, okay, we just talked about that. And deleting the pawn stuff, okay. How are we looking? 7 minutes, all right. Mesh distance fields. Mesh distance fields is a single generated data set which can cache values between frames to reduce work. Mesh distance fields feeds into the global distance fields. They're kind of the same thing. And both work with lighting for dynamic shadows, particle collisions, and distance shadows. Less mesh distance field generation or data is faster, and the system will run higher. When the player or camera moves around the world, it requires the mesh distance fields to be updated and unload and load in new data. The more items that are opted out of mesh distance field generations, this is the effect mesh distance fields checkbox on them, the more simplistic the mesh distance field representations are, and the faster that the system can render them or make new ones, maintain it, since it's done every frame. Always reduce your mesh distance field percentage on the static mesh, so you can actually it's like almost reducing like poly count. You can reduce the mesh distance field resolution, and also exclude meshes that we don't need mesh distance field on, like really small objects or items you can't see the shadows of. Within each mesh distance field, within each static mesh asset, via the modeling editor, which we can only edit custom static meshes, we can find the mesh distance field settings and lower them drastically. So here we have distance field resolution underneath the build settings for the mesh in the mesh editor, and I've reduced it to 0.1. So that you won't really notice an issue with this unless you're looking at the mesh distance field visualizer and seeing if maybe you made it too small that's too thin to generate any field at all. Then you might get lighting that will shine right through it, or particles that would blow right through it, depending on if you're using particles that collide with mesh distance fields or if the lighting is visible. Below is a comparison between per object mesh distance fields and the global mesh distance fields. The right being the global mesh distance fields, the left being the per. And what you would really just see is that the per mesh distance fields on the left is way more precise, and the global mesh distance field on the right is way blockier and way less detailed, just so you could just sort of see those two. The mesh distance fields on the left is used up close to the player, and the global distance field is used for all the rest of the world in the far distances to generate. Mesh distance fields are generated at a short distance from the player camera at a high resolution on the left. Then it is cached to the global distance field for the whole level at a lower resolution on the right. Changes require generation in the cache updates, like the camera movements from around the world, and add workload and delays to the frame rate. Everything should be done to ensure the mesh distance field generation is off and doesn't affect it, like per object. At distances that's no longer impactful to turn them off, like a max range for shadow that you can turn on. Here is a scene view and a mesh distance field view, and you just kind of see these objects. This is an example on Epic's documentation where you can drag the divider back and forth. And what I'm showing is that this mesh distance field, the black and white here, that's data that's generated. If you exclude objects, that gets less precise over here, but it's less data generated as well. So see what you can do to remove stuff from mesh distance fields, remove it from shadows, because that's going to reduce down the data and make it run faster. So there are some limitations with mesh distance fields as of UE51, which is that they won't work on non-DX11. So older systems that are not at least on DX11 won't work. Has to be at DX11 above. So beware. Characters do not show up in mesh distance fields. They're generally skeletal assets are not generated in mesh distance fields without a whole bunch of workaround. Shadows will be static and ignored on any static mesh movement from the material. And then scale. Mesh distance fields don't scale non-uniformly, so you would have to keep, when using them, you want to keep your scaling of your meshes to be uniform, or there's like a 1-to-1-to-1, not like some weird ratio. And they won't render on Intel GPUs for far shadows, so far shadows would disappear. There's some big limitations, but this is all part of mesh distance fields are a core part of the engine. These are just common issues that those other platforms have. My recommendation is to turn off effects distance fields. This would stop mesh distance field generation for small meshes like rocks, pebbles, grass, trash, anything below 6 inches to 150 centimeters. Keep shadows on, just disable effects distance fields. The local dynamic, and you can turn shadows off too, that'd be even better. The local dynamic lights will provide shadows on them up close, but this will prevent the need to generate fields on the vast majority of small bits throughout the world and add little to that distance art direction, speeding up frames and rendering. And there's some links to the document. How are we doing? 12 minutes? All right, let's get going. Mesh collisions. So if you can turn off shadows on your meshes, do it. If you don't need them, that'll speed it up. If you can turn off mesh distance fields, which does feed into shadows and a bunch of other things, turn it off on small meshes, it will speed it up. Collisions too. Mesh collisions are calculated every frame. Some do get cached, especially when we're talking about that stationary, static, and mobility types. The static and mobility types help to cache sooner and more easily versus movable. So, mesh collisions is calculated every frame, depending on the mesh mobility type. They can be cached between frames to save works. When we can reduce the collision data vertex complexity of the collision mesh, we reduce the computational workload on the physics systems. Each collision has to be checked, so the fewer collision bodies, actors, and components in the world enabled for collision, the faster the frame can complete, and the better the FPS. Collisions are seen as not just the static mesh placement, but also as hit and overlapping trigger events that can be excluded from consideration as well. So turning off generates hits, and turning off overlaps if not needed reduces the physics works that has to happen. Collision functions like mesh distance field generations, or collisions function like mesh distance field generation. So like that visual we saw above of that black and white mesh distance field visualization, collisions cache to things like that too. The more we can remove from collisions consideration, set no collision, the less field generation collision data has to be calculated each frame, leading to better frame rates. So if you can turn off collisions on stuff because you're not going to need them, it will make things run faster. We recommend setting no collisions on any asset that the player or camera will never be blocked by, and also setting the mobility to static. So here you can see simulates hits events is unchecked, generate overlaps is unchecked, and the collision preset is no collision. And I've also turned off CCD and set it to a mobility type of static. It's probably about as best as you can do. You won't be able to collide with this object, so you want to make sure it's out of the way, something you wouldn't be colliding with or okay flying through. or you could change the collision type, but you won't be generating overlap or hit events. You will want to make sure that all the functionality of your game works when the different things don't have overlaps or hit events enabled, in case you're using that for anything else. Where mesh collisions are required, reducing down your mesh collision polys, which is a separate thing that's stored via the mesh editor window, will help to simplify compute when possible. Or by adding a simple box or sphere collision is one way to do that in the editor if you only want one collision shape. And you only want one collision shape per mesh if possible. Less is best. So you could use a basic box, you could make some sort of a collision that you want to face around it, or generate one using these options here. But the idea is to try to use the least amount of verts for collision, make the least amount of data stored on the device just for collision. It will also make the physics calculations and collision work done by the engine as simpler too, versus a more complex mesh. If you wanted to do an auto convex, this is one of the ways to get one of the better shape fitting versions. Turn your hull count all the way down to 1, and then you can turn out the other things. Hull count's kind of the most expensive part, is to have multiple hulls, because it's really multiple physics objects you'll be casting against instead of just one. Here's a custom collision view. It's kind of hard to see. The pink is the actual mesh. The green here is a reduced collision mesh. And it's just sort of showing you that you could have a 16 vert collision mesh standing in place of the much more dense purple or pink column. And that would be a simpler amount of data, it would run faster. What you lose out on is fine collision on the curve. So if you were like pushing against this collision, you would see that you could push against the straight line rather than being, you wouldn't feel yourself being pushed around by the smoother edge of the extra polygons. Select collision details within the mesh editor. Using a simple 16 vert generated for all collisions instead of a complex vert if you're okay with it, each static mesh. So this is where, and set static, Fortnite static mesh is a simple static mesh if you need to build on it. And it's one of the Fortnite meshes that has the most Fortnite other channels colliding with it. It's one of the more simple static versions. Love to have some detail. There's a whole bunch of different collision presets out there, like, I don't know, 60 of them or something, and there's some charts with them too. So it's not a bad idea to go down here and look at those different collision presets and figure out which one specifically you need, because it's definitely in that direction of turning off collisions or shadows or mesh distance fields on things you don't need them to be on, is also figuring out the cheapest collision preset that you require on this item. Mesh collision optimization. Excluding all mesh actors from collisions when not reachable by the player to increase performance and reduce work. When collisions are required, simplify the mesh collision if each mesh has its, where it's possible, via the mesh editor. Player collisions viewport is right here, what we're looking at. The green is what's going to collide with players, and if you turn off collision, you'll see no player collision is on this column, and it's now gray. So that's one way you can kind of look at the world and get a view using the player collision viewport view, and you can say, hey, wait, all that stuff there up there on the wall that has collisions on it, I could take off because I never let the player get up on the wall, or things like that. So that's how you can kind of practically walk through your level and see all the stuff that you can turn off collisions on that you may not need to use, is with a player collision view. In your level, you can use non-streaming large invisible blocking volumes on top of multiple static meshes to make up collisions, like of a large floor or a wall, and I'll show you that later in the level I've created. And that allows you to turn off collisions on the smaller individual pieces that would be blocked by it. And so that's something you can think of as well as an optimization tip. This will reduce collision calculations and functions the same as a long wall that are not movable by the player. If that surface must support building, make the blocking mesh a child class of the Fortnite static mesh, so if you want to build on it. This is extra helpful if rendering merged mesh HLODs right after the camera, as HLODs don't have collisions enabled, so the blocking volume would provide collisions up to the HLOD rendering. I think we are at 20 minutes, and we're going to go into level construction next, which is where I'm going to talk about using an actor and components, the bulk property matrix, and stuff like that. So let's dig into that in the next one. Thanks for stopping in. See you soon.